Hello, and warmest of Septandy greetings to you and yours. Fun fact, did you know that Septandy is the first internationally recognized holiday not based on a religion? I'm just kidding, everybody knows that's Prime Day. Welcome to part 3 of this series, where I look back at assembly language code I wrote in high school to try to make a Moon Patrol clone. In today's episode, we're going to talk about scrolling. I thought that the scrolling of Moon Patrol was one of the unique features that made it feel kinetic and energetic and exciting, and that's something that I wanted to try to duplicate, and I knew BASIC wouldn't be able to do it fast enough, and that's maybe the main reason I started to learn assembly language in the first place. So we're going to take a look at how I did that scrolling, and we're also going to look at the main loop in assembly language to see how that all works. Let's go! Well, I've reconciled all the code as best as I can, and I now have a single assembly file with all the different versions of the assembly code that I could find, hopefully with the most recent version of everything. I did make minimal changes. I got rid of the line numbers. I added just a few comments. Most of these comments you see were already there. I reordered some things, but for the most part, I kind of left it alone. And I was quite impressed with lwasm, as it was able to just assemble this 35-year-old code that only ever was assembled with edtasm. lwasm did a fine job. About the only things I needed to change were making some branches into long branches, as you would expect anyway. lwasm did great. So let's run it, and let's look at some scrolling. I am still using a BASIC driver file, and this is just loading that version of the assembly code, the backdrop, and the data file I talked about last time, turning off the drive motor, waiting for a key, and then running it. So let's do it. Alright. Now we can see some scrolling. I'm going to point out a couple things. One of the things that I was really insistent on was doing that kind of motion parallax thing where you have stuff that's closer to you moving faster than stuff that's further away, like the real Moon Patrol did. So the ground moves a little bit faster. The real Moon Patrol has your wheels bouncing up and down as the terrain under the wheels has hills and valleys. That seemed too hard for me, so I just added these little reflector effect things to the wheels to make it look like they're turning. But not everything is all awesome here. So first of all, I was insistent also to have just a green background behind the car, so that when the car had to move, I didn't have to do anything hard. You see tearing, folks? It looks like there's some tearing to me. Like these mountains, it looks like there's a bit of a jitter or a shudder as they go across. And when you look at the vertical lines on the bottom, it seems like there's always more than one in each spot. It looks like there's 2 or 3. I'm not sure if this is just because I need to sync with the vertical sync. I mean, obviously I do need to. I don't know if that would be enough to fix it. Could it be that I'm jumping too far each frame? Could it be that I'm just jumping too frequently? Is it like a visual illusion, or is there real tearing? I don't know. That might be something to investigate. And finally, maybe it looks like I have this endless stream of terrain up here that I'm scrolling into view, but no, the deep dark secret is I'm not really scrolling, I'm rotating. If you look at the left side, you'll see that whatever rolls off the left is exactly what comes into the right. I'm just rotating from right to left and then back again to right. So this is a very finite set of terrain. Same with the bottom, all these little bumps. All I'm doing is just a very simple, sleazy, slimy rotate. So here's generally how things work. There's a main loop that just keeps repeating. There are no interrupts, there's nothing complicated, just one loop. And controlling everything is a counter. So this routine will increment a counter variable, and then there's this other variable counter condition that's either 0, 1, or 2. It's basically the counter mod 3. And what it lets us do is either achieve some action every time through the loop or only a third of the time through the loop. You know, it kind of determines like when something should happen. So for example, if we're in the middle of jumping the car, we'll go ahead and jump the car. But only if the counter condition is 1 will we actually move the car. This, I think, moves it left and right. And then when we get down here, there are a few things that only happen if the counter condition is 0. If it's 0, we'll handle bullet shooting, we'll handle rotating the mountains, we'll redraw the bullet, and then we'll skip back here. But if the count is not 0, we will still do some of the shooting things. So some of those happen, I guess, every time. But definitely the mountains only 1/3 of the time. And then if we are in the middle of jumping the car, then we'll handle that, and we rotate the ground every time. So every time through the loop. And that's the whole loop. So let's see how I'm actually doing the rotating of the mountains and the ground. So if we use rotate mountain as an example, actually we can put both of them on the screen. They just set up some variables and then call the general purpose rotate routine. So this general purpose rotate routine has the X register pointing to the upper left-hand side of whatever rectangle you're trying to rotate. And then this vertic variable tells you the vertical length, the height of that rectangle. And I guess it's understood that the width of the rectangle is the entire screen. I added some comments. The rotate routine is just a simple nested loop. So the outer loop does one row at a time, one horizontal line of the screen at a time. It starts off by remembering what the leftmost byte is, saving that onto the stack, and then sets up a counter. There's 32 bytes per line, so the counter goes from 31 down to 0. And then the inner loop moves forward just 1 byte to grab the byte we're going to move, and then stores it in the current spot, and then advances X. So it just keeps going like from here to here, and then from here to here, and then from here to here, and then from here to here. For each byte, we decrement our byte count that we set up here, and if it's not 0 yet, we go back up to the top of the inner loop. And then when we're done with that row, we restore that original byte that we overwrote from the left-hand side, and we put it in our current spot, which is the right-hand side. So this is what does the rotation from left end to the right end. Then we decrease the vertical count because we're about to do the next row, and that's what this does. This goes back up to do the next row. So you'll see this is not going bit by bit. So we're doing a full 8 bits at a time, and in this resolution that is, I think, 4 pixels because it's 2 bits per pixel. So this could be part of why it looks a little jarring, is that things are kind of skipping 4 pixels at a time. To help see this better, I added a keystroke wait so that each time through that main loop you have to hit a keystroke for anything to happen. So I'm going to hit here, the ground moves, both move, ground, both, ground, both. And if you keep your eye on either of these, I think you'll see that they each advance by 4 pixels whenever they do advance. So I think it's easier to see on the mountain. So 1, 2, so the mountain is like right here at that height. And then my arrow disappeared, but I think it advanced like these 4 pixels. And the ground looks like it's going by 4 as well. Meanwhile, if you look at the reflectors, they seem to go every keystroke. So there are a number of things I could do to improve this. I could use an off-screen buffer, because right now I'm just making changes to the screen that is being rendered as it's being rendered. Along those lines, I could also try to coordinate with the vsync interrupt to avoid making any changes until after the full screen has been rendered. I could also scroll by a smaller amount. Rather than going by byte, I could go by pixel. And I could also improve the efficiency of how I'm doing the scrolling by stack blasting or some other technique that's a faster way to push memory around. I don't know, but I'm definitely not going to do either of those next. The next thing I want to do is to explore more of the code.